Okay, well, happy Friday, and it's the end of week 4, and starting Monday, I will be back on campus, and I will be teaching this class in person. And thank you to everybody who responded to the survey, just to kind of get a pulse and see how you guys were feeling. And the results were very mixed. Some students are excited to be back in person, and some students very much don't want to go and be back in person. Some students are very concerned about COVID, and other students are not. So it's quite interesting, the results that have happened. When I asked about exam accommodations, by far, most of you, almost all of you, said you are able to take the exam, in person as scheduled, and you don't need accommodations. But several of you expressed, some concern, just about being in a crowded classroom and whatnot. And so the midterm exam is scheduled for February 9th. It will be in person. I was able to schedule a classroom for the evening of February 9th as well. And so, our class, this class 102A meets on, at 10 a.m., at 11 a.m. And our current classroom has a capacity of, I think, 98 students. And that's like max capacity. And we have around 80 students enrolled. And so if everybody shows up, it's going to be pretty crowded in there. And so to kind of reduce the density of students in the classroom, I was able to kind of get another classroom scheduled in the evening. And what I will do is I'll kind of split students between kind of morning and evening. I'll probably send out a survey asking, what's your preference, or, if you absolutely have to take it in the morning or something. And if you're and if everyone's kind of okay with this, well, then what we'll do is, I'll just kind of assign students to take the exam in the morning, and some students will take the exam in the evening, and that will kind of reduce classroom density. So, maybe only 40 students in the 98 person classroom will take it at, 11 a.m. and then 40 students will take it in the evening of February 9th. And it presents some logistical challenges and things like that. And so I hope you guys will work with me and, just kind of be flexible, as far as rearranging times and schedules. And so, I'll send out a survey. And again, if absolutely you cannot take the exam in the evening or something, you can let me know in the survey. And then, and other than that, everybody else who's kind of available and flexible, then I'll just randomly assign some of you to take the exam during the day, and some of you will take the exam at night. And we'll go from there. And that's again, that's the plan and the goal and the desire was to reduce the kind of density of people within an enclosed space. I know everybody's going to be wearing masks and things, but I know a lot of students also had concern about being in a crowded classroom. So that will be the case. Again, we will be back in person on Monday. I will continue to record my lectures, and I will post them online. I won't be like live broadcasting while I'm in the classroom. It's just too difficult for me to pay attention to the classroom and pay attention to what's happening on Zoom. Also, when you have Zoom open, it adds a bunch of kind of like windows around the screen, which is fine when I'm at home because I've got 2 monitors and I can kind of keep one monitor for Zoom stuff and one monitor for the lecture slides. But when I'm in the classroom, I just have my laptop and only one screen, and having it cluttered with the Zoom stuff makes it challenging for me. So anyway, I'm not live broadcasting during the lecture. I will record it and I will post it up as soon as I can. So it'll get up by 1 p.m. The day of the lecture. So So I'll probably try to get it posted during my office hours session. So if you don't attend live, you can keep up with the lectures. Just wait for the links to get posted. You'll find it. You can whatever, watch it at 2x speed, search for the view quiz answers and things like that. But as long as you're kind of participating and responding to the view quiz answers, you'll get your points. My hope is that you are indeed paying attention to the content and absorbing the material that I'm presenting. The office hours, I've got my office hours schedule, and this is still going to remain the same, where my office hours schedule. So Mondays and Wednesdays, 12:30 to 1:30 will be in person and online. And then the other office hours sessions, so Tuesday mornings, Wednesday evenings, Thursday evenings, those are all online. And then Saturdays are also online. But the ones as far as in person and online, I'll have Zoom open, but also people there. And just kind of, I think human tendency and my tendency is to kind of pay attention to the people who are in front of me. And so if you are online, if you come to Zoom office hours online while I'm also talking to people in person, I'll try to make sure I pay attention to you, but if I'm not, or if I don't notice you, feel free to just unmute yourself and say, excuse me, professor, and I'll you'll get my attention that way, and I can kind of address your questions or issues, and maybe I have to say, hang on a second or whatever. But that should be good. Okay. Any kind of questions as we start to transition back, or at least are planning for starting back up on Monday? Okay, so that's the plan, and so some of you, I will see you in person on Monday. Okay, we are continuing on in our lecture on what do you call it? Regular expressions, and we left off in our last session talking about regular expressions, and we had introduced character sets, and we said, when you use a square bracket, whatever letters or characters you put inside, it will match one of those characters, and so we can define a character set to match all of the digits as 0 through 9 inside the square brackets. Now, this is such a common thing. So the lecture slides are the same lecture slides from Wednesday. So the Wednesday lecture slides is like 162 pages long or something. So it's the same thing, and I'm picking up off on slide 61. So I haven't posted a separate document for today. But this is such a common thing that we want in getting digits. We have kind of a shorthand for it, and it's \D. Okay. Some students were asking, do I have to memorize all of this? Okay, you don't have to memorize all of this. On the midterm exam, I will print out this cheat sheet. Okay, this cheatography regular expressions cheat sheet. I will include this on there, and it has a lot of this information. \D is for a digit, character class. \D for a digit. Now, in R, anytime you use the backslash, it's got to be double escaped, or you got to kind of use the double backslash. So here I put double \D. In normal regular expressions, it's just a single \D, but because we're talking about R, I have the double \D here. Okay, so anyway, this is any digit is double \D, 0 through 9. You got word characters, which is basically the 26 letters of the alphabet, both uppercase and lowercase, plus the digits 0 through 9, plus an underscore. That counts as a word character. So basically anything you can use is kind of like a username for an email address or something like that will count as a word character here. And then whitespace, basically being spaces, both breaking and non-breaking spaces, new line characters, tabs, all of those are white space characters, and the shortcut there is \s. Okay, and if you don't want to match those things, you use the capital letter. So little d, \little d is for digits, \capital D is for non-digits, \little d is word character, \capital, I'm sorry, \little w is word character, \capital W is non-word character. What is a non-word character? Non-word character would be things like a comma, a dot, an exclamation point, things, basically punctuation and symbols and other types of things. Spaces are non-word characters. Okay. A white space character is \little s, and if you don't want white space, it's \capital S. So everything's very case sensitive because that's the difference between you do want this thing and you don't want this thing. Oh, I'm not sure. Are you guys familiar with what a non-breaking space is? A non-breaking space? Okay, so a non-breaking space. So, all right, so, I love the city of Los Angeles. Okay. This is going to be my text here. Okay. I love UCLA. I love the city of Los Angeles. Okay. So when you have a non-breaking space, anytime you enter like a word here, as I was typing this, right? So as this gets bigger, right? So we'll say, I love UCLA space. And as I increase this, it encounters a space here, right? It reaches the end of the thing. And so it breaks up Los Angeles. Now, this is normally, this here is a non-breaking space. Now, what I can do is I can do, how do I get my non-breaking? How do I insert a non? It used to, I thought it was Alt space, but it's not. Hang on a second. How to insert non-breaking space in Word. Video. Oh my gosh. Everything's a YouTube thing. Okay, answers on Microsoft. Control Shift Space. Okay, Control Shift Space. That was it. Okay. Control Shift Space. There we go. That's a non-breaking space. Okay. Now, when you have a non-breaking space, so this one is the breaking space. This is the non-breaking space. In regular text, it looks the same. But watch what happens. So here I write, I love UCLA. This is the non-break. This is the breaking space. I love UCLA. When it reaches here with a non-breaking space, it will not allow the two words to be separated onto different lines. Okay. So normally when you reach the end of the line, right? And if you expand the margin, okay, to fit it, it will go. And then when it can't fit the word anymore, it pushes the word to the next line. Okay, this is the non-breaking space. The non-breaking space is it's treated almost like a character where it won't allow it to go on to the next line. Whereas this one, it will create a space between the Los and the Angeles there. Okay, so that's the difference between a non-breaking space. All right, so anyway, white space characters, that includes both breaking and non-breaking space characters here. Okay, there's a whole bunch of different white space characters. You've got form feed, new line, carriage return, tab, vertical tab. I don't even know what a vertical tab is, but a \s is a way to kind of match all of the white space characters. Oh, a question, do I prefer Bing over Google? No, but but I didn't bother changing my default search engines. It's fine. I use whatever, each of these browsers, I've got different search engines. So yeah, I use Google a lot, but I also use Bing, sometimes DuckDuckGo, and I don't know, I see different results, and they're usually okay. Character class. Okay, so here let's take a look at what will this match. I've got P followed by /D, \D. So this is going to be P followed by a digit, and what will it match? Okay, it will match the P0, and that's it. Nothing else is has P followed by a digit. So we get false everywhere. We get a true for P0 and false for everything else. Here I've got P followed by a non-digit. Okay, so that's going to match everything except this. So it'll match this. This is P followed by a dot. Dot is a non-digit. So it matches all of that. This is we get true there. The only one where we get false is P followed by a digit. This is P followed by a word character. I'm sorry, P followed by a non-word character. It's a capital W. Capital W, P followed by a non-word character. So the only one where it's not a word character is P dot. P dot is a non-word character. That's the only one that matches true. Everything else is false. We also have other ways to match kind of character sets or character classes, and these are known as POSIX character classes. And R works. This works with R, and it should work for most of your computers. Although some students had encountered trouble using their POSIX classes, and I'm not quite sure why, but it should work. It should work. Okay. And again, these are also in the cheat sheet. Okay, you've got these kind of POSIX characters, and so you can say alphanumeric, and this is the same as that. Alpha is any letter, the 52 upper and lowercase letters, digits, lowercase, uppercase, white space, punctuation, and so some of these don't have kind of matchable things here. Okay, and this is how we do it. And within R, though, if you wanted to use a POSIX class, they need to be inside another set of square brackets. So you're going to have kind of this double square bracket. And again, these are just some of the quirks of using regular expressions in R, is you have to kind of use double backslashes, and you have to use these double square brackets if you're going to do a POSIX class and things like that. Okay, so any string that contains a letter, okay, so that's going to match all of these things. Okay, any string that contains a digit, okay, well, this contains a digit, this contains a digit, and so we get true for P0N, true for PWN3D, and false for anything else. We have anchors. Oh, I've forgotten. Have I given you any view quiz answers yet? No. Okay, let me go ahead and give you your first view quiz answer. Today's first view quiz answer is the letter C. C as in cat. C as in cat is your first view quiz answer. C as in cat. Anchors tell us to match based on a position, So we can declare match at the start of the string, or match at the end of a string, or match at a word boundary, or not a word boundary. For the start of the string, you can use caret or \A. To match the end of the string, you can use $ or \Z. So let's take a look at this, okay? So here I have just one string, and it's the quick brown fox jumps over the lazy dog. And here dog is repeated twice, and you know, this contains all of the letters of the alphabet. We're going to match any instance of THE. So we're going to find an instance of THE here, an instance of THE here, and it will replace them with a dash. Okay, so we get dash quick brown fox jumps over dash lazy dog. Here says it must start at the start of the string. We've got the caret, so the start of the string is kind of this invisible boundary between the opening quote and the first character. Even if the first character is a space, it's the boundary between the opening quote and the first character is the start of the string. So it says, looking at the start of the string, the first character has to be a T, then an H, then an E. And so it's only going to match this, okay? Over here we have THE, but it is not at the start of the string. There's a space before it. And so it's not going to match that. And so it's going to just match the dash at the beginning. Okay, we get a match here, nowhere else. This is the exact same thing. This is just another way of expressing the start of the string. And so we get the exact same results. And here it says THE, and then it has to be at the end of the string. Okay, again, the end of the string is this kind of boundary right before, right at the closing quote. It's the boundary right at the closing quote. And there's no THE followed by the end of the string boundary. So there's nothing to replace. There's no match to be found. And we just get the original text back. Here, I'm going to replace any pattern of DOG with a dash. Okay, we're going to get DOG with a dash. And this is what we get. The quick brown fox jumps over the lazy dash dash. And that is our response there. String replace all, we have DOG $. Okay, we're going to find any instance of DOG at the end of the string $. Here. And we've got dog $. We're going to replace that with a dash. And we get that. The quick brown fox jumps over the lazy dog dash. All right, we have another instance of text, words, jump, jumping, umpire, pump, umpteenth, lumps. And here we're going to search for all word boundaries. Okay, word boundaries exist at the start and the end of a word. They are not characters. They exist invisibly between the end of a word and the next character. So the end of the word is S, and the word boundary is between the S and the space. I also have a word boundary between the space and the letter J. I have a word boundary between the letter P and the space, a word boundary between the space and the next letter J, and so on and so forth. So we're going to, right now, you don't see the word boundaries. They are not represented with any kind of characters, but we're going to replace all word boundaries with a dash, or put them in there. And so now the word boundaries are visible to us. We can see the word boundaries that existed here now have dashes. And so we have a word boundary before each word. We have a word boundary after the last letter of each word. Okay. And again, the word boundaries are not the space characters or anything like that. It's just at the start or the end of the word here. So if you have punctuation with like commas and dots and things like that, that also serves as a word boundary. Okay, we can also look at non-word boundaries. Non-word boundaries are basically boundaries between letters or characters within a word. So you have a non-word boundary between the W and the O, a non-word boundary between the O and the R, a non-word boundary between the R and the D, and so on and so forth. And we can make, currently again, in this original text, they are invisible to us, but we can make them visible by replacing all non-word boundaries with a dash. And so we get dashes between all of the letters within a word. So we have W-O-R-D-S. Okay. Nothing appears between the S and the J because there's a space, and those are word boundaries. So if we're asking to replace non-word boundaries, then that's what we get. Okay, let's take a look at this pattern. Here we are saying, I want a word boundary followed by UMP. So this basically means find any instance of UMP at the start of the word, UMP at the start of the word. So we have jump, jumping, umpire, pump, umpteenth, lumps. It's going to match UMP in umpire and UMP in umpteenth. This is UMP at the start of the word. And so if we replace those with dashes, we get the umpire and the ump and umpire gets replaced. The ump and umpteenth gets replaced. This says find a non-word boundary followed by UMP. So this is UMP, but not at the beginning of the word. UMP, but not at the beginning of the word. So we're going to find the UMP and jump, UMP and jumping. This is, there's a word boundary, so it's not going to match that. UMP and pump and UMP and lumps. So those get replaced with dashes. This says UMP followed by a word boundary. So this is going to find UMP, but only at the end of a word. UMP only at the end of the word. So it'll get jump, the UMP in jump, the UMP in pump. It has to be UMP followed by a word boundary. And here I have UMP followed by a non-word boundary. So UMP, as long as it's not at the end of the word, we're going to get the UMP here, the UMP in umpire, the UMP in umpteenth, and the UMP in lumps. And that's what we get. All right. Any questions about using these word boundaries or non-word boundaries? All right. So here's a question. What is the difference between caret and caret and then character set 0 through 9, character set caret 0 through 9, and character set 0, 9 caret? Okay, and so the meaning and usage of the caret changes depending on its position. So when you have caret outside of a character set, it serves as an anchor. So this means match a digit, but it has to be at the start of the string. So matches strings that begin with a digit. When you have caret inside the character class at the start, this serves as negation. So this is going to be match a character set that is not a digit. Match a character set that is not a digit, right? So this is not 0 through 9 characters. And here we have 0 through 9 caret. So this matches, and when it's not at the beginning inside a character set, okay, this is a literal caret character. This is a literal caret character. So we're going to have 0 through 9 or the literal caret character. So a digit or a caret. All right, let's take a look at quantifiers. Quantifiers can be attached to basically any kind of literal character, character classes, or groups to match repeats. And you can match with a star, getting 0 or more. You can match with a plus to match 1 or more. You can get a question mark to match 0 or 1. You can get curly brace 3 to match exactly 3 of those things. Curly brace 3 comma to match 3 or more. Curly brace 3 comma 5 to match exactly 3, 4, or 5. And of course, you can replace any of these numbers 3 or 5 with some other integer. So let's talk about replacing whitespace characters. So right now I'm not using any quantifiers yet, but here let's match. Here's the string words or numbers 987, 9876 and combos 1, 2, 3 or whatever. Okay, so we're going to replace any spaces with a dash, and we've replaced all of the space characters with a dash. Okay, let's replace all non-space characters, capital S, non-space characters with a dash. Okay, so now I've got a whole bunch of dashes, dash, 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 dash. Space, dash, dash, space, dash, 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 dash. Okay, so this is what we get, all right? So it's all of these characters have all been replaced with a dash. Okay, this is where I use the quantifier for the first time. Here we're going to say one or more space, non-space characters. So one or more characters that aren't a space. So non-space characters. So when it reads left to right. It's going to say, okay, this is not a space character, that's a match. And there's a plus, so it says, can you get any more? So we're going to match the O, the R, the D, the S. This all matches one or more non-space characters. Then we hit a space, so that ends the match. So that no longer matches. So we're going to say, okay, this entire thing, WORD, is a match we put in a dash, okay? We come here, these two characters also match, and we replace with a dash. And we also have this, all of these characters, one or more, we can replace with a dash, okay? And so this is the result, dash space, dash space, dash space, so on and so forth. String replace all, we have \w plus one or more word characters, word characters. So this is similar to this. These are non-whitespace characters. Word characters are basically all letters and numbers. The only thing that's different is that the comma is not a word character, okay? So again, the result's going to end up looking almost exactly the same, except where 9,876 was replaced with a single dash. Now we get a dash for the 9, we have a comma, and then a dash for the 876 here. We can replace any digit with a dash. And so we'll replace all of these digits here, the 1, 2, 3, the 1, 2, 3, 4, those get replaced with a dash. And that's what we get. We can put in non-digits. We replace any non-digits with dashes, okay? And non-digits include letters, anything that's not a digit, including the spaces. So everything, all of these, we get replaced with a dash. The comma gets replaced with a dash. Everything else gets replaced with a dash. So anything that's not a digit gets replaced with a dash here. And again, here we're just saying replace one character at a time. One character that is a match, any one non-digit is a match, we replace with a dash. I can change this to say I want to match any one or more digits. So we're going to get the 9 gets replaced with a dash. The 876 gets replaced with a dash, one or more digits. Combos, the 1, 2, 3 here gets replaced with a dash, and the 1, 2, 3, 4 gets replaced with a dash, okay? And if I say one or more non-digits, all of these consecutive non-digits count as a match for non-digit one or more. And so all of the consecutive non-digits will get kind of replaced with one single dash. Okay, all of these get replaced with a single dash here. And that's what we get. Okay, here's another example. And this one's a little bit strange. We're going to say /d question mark, 0 or 1 digits, 0 or 1 digits. Okay, and so this will look at things like word boundaries and non-word boundaries and replace those with a dash. Okay, so it finds 0. There's 0 matches here. 0, and it's kind of like the word boundary, and it replaces that with a dash. There's a 0-digit match between the T and the H. It's like the non-word boundary, and those get replaced and things like that. These consecutive digits here, the 1, the 9, and the 6. Okay, if it can match 1, it's going to replace it. So these get replaced with dashes as well, and so this is what we end up getting. Here I'm going to say replace exactly 3 digits with a dash. And again, it reads left to right. So we have the year 1996, area code 310, combo 123, passwords _1234, single digit 5. So it reads left to right. It's looking for 3 digits in a row. And we're going to get it finds a match at 199 and it replaces 199 with a dash. And then it starts at the 6 and it says, okay, well, I don't have 3 digits in a row. So it leaves that as a 6. Okay, 310 gets replaced. That's 3 digits in a row. 123 gets replaced. That's 3 digits in a row. 1, 2, 3, 4. The 1, 2, 3, again, it's reading left to right. Finds a match. It replaces it. The 4 stays intact. Single digit. The 5 is not a match because it requires 3 to be in a row. Okay, here it says match 2 to 4 adjacent digits, 2 to 4 adjacent digits. The 1996, all 4 gets replaced. 310 gets replaced. 1, 2, 3 gets replaced. 1, 2, 3, 4 counts as a match from 2 to 4. And then 5 is all by itself, so it doesn't match, and that remains. Let me give you your second view quiz answer today. Today's second view quiz answer is the letter B. B as in bear. B as in bear is your second view quiz answer, B. Can you do comma 5, meaning 5 or less, the way we did 3 or more? Yes, yes, you can do comma 5 to do 5 or fewer. 0. Is it 0 to 5 or 1 to 5? Ooh, I think. Actually, let me see. Let's see if we have. Or maybe we can't. Maybe just do 1. At least do 0 through 5 or something like, or 1 comma 5 or 0 comma 5. I'm not sure. I don't remember. Okay. All right. I said when you have the star or the plus, it's greedy. And so what does it mean to be greedy? Greedy means it's going to try to find the longest thing that matches the pattern. Okay. And if you add a question mark, it makes it ungreedy, which will find the shortest thing that matches the pattern as it reads left to right. So here the pattern is capital P dot star, which means any character, spaces, letters, any character, 0 or more of them, ending with an R. And so we've got capital Peter, Piper, picked a peck of pickled peppers. And the greedy match says, capital P, great, we found a match. We're going to keep going, dot star. We're going to keep going until we encounter an R. And it says, well, can I keep going? And it goes, yes, 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 yes. And we can go all the way up to here because this starts with a P, ends with an R, and it's got a bunch of wild characters in between. And so the match is going to be all the way, Peter Piper picked a peck of pickled pepper. Okay, it's going to find this entire match here. If I say, no, don't be greedy, okay, I put in a question mark after the star. So P, capital P dot star question mark. It says, don't be greedy, find the shortest match that kind of matches the pattern. So we got capital P, E-T-E-R, and that's a match, and it ends. And it says, Peter, this matches, this is the end. Okay. String extract all says, okay, find all the matches of capital P ending with an R. So Peter matches, then it finds Piper, capital P, ends with an R, and there's no other capital P's, so it just gives us back Peter and Piper. Here I make my pattern and I define a character class and I say, well, match it if it's got a capital or a lowercase p, capital or a lowercase p, ending with an R, ungreedy. It reads left to right. So it's going to find Peter. It's going to find Piper. And then it finds lowercase p for in picked. And it says, can I keep going? And it ends up here. Okay. Now, it technically, PER down here matches this pattern. But again, it reads left to right. So it first finds this P here. And it finds a match and it keeps going. Technically, it could do this, but again, because it reads left to right, it finds the capital P and it keeps going until it finds an R. So it's going to get Peter, it's going to get Piper, and then it's going to get picked a peck of pickled pepper. Okay. And it's not going to just try to find this the smallest possible thing over here, right? It reads left to right. We have capture groups. You can use parentheses to define groups and capture groups. And basically we group like regular expressions together. And you can also cause your group to be a non-capturing group. I think it's going to be easiest to just show some examples of this. Okay. And then and to use capture grouping things, we've got string match and string match all. So this A with parentheses BCD says match the text ABCD and the capture group is BC. This would say match ABC, but don't capture it. This says match ABCDEFGHI, and the capture groups are ABC and GHI. If you want to use OR with the vertical lines here, it's got to kind of be inside a grouping in a group. Okay, you use groups to kind of group these regular expressions together, and you can use ORs here. Okay, so you got Mrs. or Ms. or Mr. That and it's given in kind of preference is given in the order that it's specified. And then if you want to ever refer to capture groups that have been defined, you can use \1 and \2. So so yeah, the or the alternation operator is the vertical bar. Okay, so non-capture groups, it seems a little silly to use non-capture groups in a literal pattern. I mean, you can just say not include the parentheses, and it'll require the pattern to be there, but it won't even capture it. But non-capture groups are useful if you want to use kind of the alternation, the OR operator here. So this says match BCDEFGHI, capture the group BC, capture the group DEF, don't capture the group GHI. So here's the text we're going to match. It finds a match for the pattern BCDEFGHI, and it pulls out the capture group BC, pulls out the capture group DEF. Okay, here's the text ABCDEFGHI, capital I, and that doesn't match this pattern at all because it requires a lowercase I, and so it says it doesn't find a match. All right, so here's an example that might be a little bit more compelling. I've got this text, Mr.Smith, comma, space, Mrs.Lee, comma, space, Ms.Garcia. And our pattern is capital MRS or capital MS or capital MR, okay, in that kind of pattern. And we're going to search for this inside this thing. And what do we find? Yes, we find MR, we find MRS, we find MS. Okay, no problem. Now, preference is given to the order that it's provided. It reads left to right. So if I list MR before MRS, what happens? As it's going through here, it finds a match at MR and it says, ah, I found a match at MR. But then for Mrs. Lee here, it finds a match at MR and it goes, ah, I found a match at MR. My job is done. And it returns MR. Okay. If I want the MRS to match, I've got to put it kind of listed before, because otherwise, giving preference to the shorter one, it's always going to match this before it matches this. Right. So here with MRS followed by MS or MR, then it will match the full MRS and return that before it tries to match MR. Okay. Does that kind of make sense? The difference between what's happening here and here, just by kind of swapping the order of the patterns inside the character group and inside the grouping example. Here's a shorter pattern that could work as well. We can say M, R is optional, S is optional, question mark makes it optional, 0 or 1. And so this will match MR, this will match MRS, and this will match MS. The issue with this thing is that this will also match capital M by itself. This will also match capital M by itself, which perhaps we don't want to match. We can make our regular expression pattern a little bit more useful by saying, you know what, not only do I want to make sure I match MRS, MS, or MR, okay, I also want to kind of get the name that follows that. So we can say the title, MR, Mrs., Ms., or Mr., followed by a dot, space, a literal dot and space, and the next set of word characters, put those into a group and capture it. So when we run this, what do we match? We're going to match Mr. Smith. The MR is in one capture group. And then this part, the words that come after the space are in its own capture group as well. So we're extracting out the last names, Smith, Lee, Garcia, okay? Now I tacked on comma Andy Hope here, and this is not a match because it doesn't match this pattern here where there's a title, Miss, Mrs., Mr., Mr., something like that. So this is what we have, okay? Does that kind of make sense as far as how this works, okay? And so now we might just say, well, you know what? I just want to get the last names. I'm not interested in actually capturing the title itself. So I can put in a question mark colon to make this a non-capture group. So now I have a non-capture group. And so we require that this thing exists as part of the pattern we're going to match. So Andy Hope still doesn't match. And out of these things, we can extract out the last name, Smith, Lee, Garcia, without kind of pulling out the actual title itself. Okay. And so you'll probably end up using something kind of similar to this when dealing with the managers column in your homework and things like that. Okay, there's a question. Why is the result 3x2 matrix? Are you talking about this thing or which one? Which 3x2 matrix are we looking at? So for something like this, when you use string match, the first is the pattern, what text matches the pattern, and the second is what is the capture group that is defined. Now here, because the entire pattern is a capture group, these two columns are identical. Okay, over here, the first column is the entire text that matches the pattern, and I have two capture groups, so the additional capture groups get extracted. So this is the first capture group, that's this column. This is the second capture group, that's this column. So this is the entire text that matches this pattern. MR at Mrs., Ms., or Mr. followed by a dot, followed by a space, followed by one or more word characters. This matches that pattern. MR dot space, one or more word characters, that matches the pattern. And as far as the second column goes, this is the capture group that we want. This is technically a group, but we're only grouping here because I need to use kind of the alternation operator, and I don't actually care about capturing this. So I put in the non-capture symbol. This is the group I do want to capture, the last name, and that's what we have here. This, okay, I'm going to run out of time here. Let me give you your last view quiz answer. Today's last view quiz answer is the letter E. E as in elephant. E as in elephant. Okay, let me just go over a couple examples here. Here I've got George Washington, comma, John Adams, comma, Thomas Jefferson. Our pattern that we're going to match is going to be word character, space, word character, comma, and the comma is optional. So when we match this, we get a match at George Washington, comma, with capture groups George, Washington, John Adams, comma, with capture groups John, Adams, Thomas Jefferson, Thomas, and Jefferson. Okay, we're going to replace this pattern. We're going to match the pattern of words, word, space, word, comma. We're going to replace it with a back reference. By referencing, we want to replace it with the second capture group, which in our case is the last name, comma, space, the first capture group, George, followed by a semicolon. And so when we do this, George Washington, John Adams, Thomas Jefferson gets replaced with Washington, comma, George, semicolon, Adams, comma, John, semicolon, Jefferson, comma, Thomas, semicolon, right? We are referring to what we captured, and we're using those to kind of create our new text thing by using the references to the capture groups that we found. Okay, what is this? What is this? So this pattern, okay, and so I've got more examples and we're going to run out of time. I'm not going to be able to go over all of them. But this one says, I need a word boundary followed by word characters, followed by one or more space characters, followed by a reference back to the first capture group. okay, followed by the group of text that was captured earlier, that first reference back to the first capture group, followed by a word boundary. So what is this going to match? Okay, this is going to match any instance where a word is repeated, because we're saying capture group followed by space and the capture group. So if the word is repeated, in this case, that's going to match this. Okay, there's more of these things. Here's a regular expression to kind of find a phone number. Okay, and this is kind of a, again, when you first read regular expressions, you look at this and it feels overwhelming and scary. And so I've tried to break down what exactly is happening, okay, with each of these things. So this is an optional opening parentheses, a capture group consisting of a digit between 2 through 9, followed by any 2 digits, followed by an optional closing parentheses, an optional character of dash, space, or dot, a literal dot, okay, that's optional, followed by basically digits 2 through 9, followed by any 2 digits, an optional dash, space, or dot, and any 4 digits. Okay, and that's going to be the capture group. And so when we apply it to something like this, it's going to pull out things that look like phone numbers. Okay, I do encourage you to take the time to read over and look over these examples for regular expressions, and you have a little bit of homework dealing with the regular expressions when you're, working with the manager's columns and things like that. Okay, that will be it for today. Have a great weekend, and some of you we will see on Monday in person in class, and others of you just stay tuned for the video to be posted.